Hello, welcome back. Online people, hopefully you can hear us. Put like something in the chat, but I'm pretty sure you'll be able to hear me. I'm pretty loud. I'll just yell. We're back again, another week. Is there any new people this week? One, two. Oh, look at all you new people. Welcome. You missed out on Marco last week. Oh, what happened? Sorry about that. Anyway, you made it for Reza, so that's good. That's good. This is the Melbourne Power BI Fabric meetup. We're having like a superstar month this month. We had Marco last week. We now have Reza, which is great. Just a quick shout out to our sponsors. So the first sponsor is Cognizant. They have these lovely offices. If you want to come and work at Cognizant and talk to a Cognizant person near you, they also sponsor our drinks and obviously the venue. And so if you're in the enterprise space and you need things, then think about Cognizant as an option. We also want to thank Sirius People. We've got Joe over here from Sirius. So Sirius People are recruiters. So if you're looking for people or you're looking for work in the data space, talk to Joe or talk to Bryson, who's our regular attendee here. So have a chat with those guys. They're great for letting you know, even if you're just wondering what's happening in the market at the moment. The market's been pretty weird in the BI space, and so it's good to chat with those guys. I'll let you know kind of what's happening, who's recruiting, who's looking for work, and all that kind of stuff. So thanks to Sirius People. They sponsored the pizza. So hooray for them. Well, thank you, sponsor. This week, I'm not going to do too much of an intro. I think this person is pretty well known. Is there? No, I'm not going to ask if anyone doesn't know Reza. I'm pretty sure everybody does. Shelley's here. Hi, Shelley. Obviously, somebody who's very influential in the Power BI space, has been here since day dot. I can attest to that. Radacad.com, the great website. You've got a whole lot of stuff on there. Reza obviously does consulting and training, and he's been on a world tour. So he's been doing a lot of fabric training. So we're very lucky to have him. He's made his way down to Melbourne. I think Reza's got lots planned. So he's going to talk to us about Fabric Direct Lake. Very interesting topic. So, and Reza always does a great job. So let's give it up for Reza Rad. Thank you very much.
Thank you. Thank you, Greg. Thank you, everyone joining. Am I loud enough for everyone to hear? Okay. I'll try to not shout that much. Like last week, I had a little problem with my voice. This week is good though. Okay. This session is about Power BI Direct Lake in Fabric. How many of you using Power BI? Like pretty much everyone. Fabric? Not so much. Okay. I originally have it with this slide, but someone told me that is not really original Fast and Furious style. So this is the Fast and Furious Power BI Direct Lake. About me, I'm Reza Rad. I'm a Power BI Microsoft Fabric consultant, trainer. I have written some books on Power BI, nothing on Fabric yet. Something coming up. If you are interested in learning about Fabric or Power BI, I do blog often on Radacad website. How many of you are familiar with Radacad website? Okay, cool. Welcome back. Yeah, connect with me over there. If you have any questions, I'll be more than happy to look into that. And that's pretty much it. Okay. For those of you that Fabric is a new thing for you, I'll do a little bit introduction, just a warm up to say what it is. But then we'll jump mainly into the Direct Lake section. Fabric is a software as a service solution provided by Microsoft, which is like an umbrella solution coming from three main products in Microsoft: Power BI, Azure Synapse, and Azure Data Factory. Combination of all of these three products gives you pretty much everything that you need in an analytics space, from data transformation at a scale with powerful data transformation tools such as data flow combined with data pipeline to do data orchestration, things like that. It gets the power of Synapse to build a data warehouse at a scale, or data engineering with the Spark engine backend, parallel processing engine. You would have the ability to do data science project within this environment, real-time analytics. And then you have, of course, Power BI, which is the tool that Pretty much all of you know about it. It is the tool that we can do for self-service visualization and any dashboarding reporting on top of it. All of these together comes as one product called Microsoft Fabric. This Microsoft Fabric different workloads, as we call them, these workloads are using one storage layer across all of these called OneLake. This is the place that all the data would be stored, either files or the data tables, everything like that. The OneLake is like a logical layer of storage. Underneath, it uses Azure Data Lake storage. All the data gets stored with it. You can add more governance in this whole suite using Microsoft Purview. Microsoft Purview, however, is not part of the product. That is a separate thing you have to purchase. But in Microsoft's marketing material, it is always part of Fabric, which is kind of interesting. And then, of course, this is the age of Copilot, AI. There is no session these days that doesn't have anything with Copilot. So Copilot and AI is also embedded in different parts of it. We have Copilot in Data Factory, in data warehousing, data engineering, data science, and Power BI. All of these areas you can use Copilot, depending on the capacity that you purchase. This is a software as a service solution that is capacity-based licensing, right? So you go and purchase different capacities, and different capacities will give you different compute power. If you want to use something like Copilot, you have to use what we call as F64 or higher. But anyway, I'm not going much into the licensing side of things. We can talk about it in the Q&A. Let's do demo, right? Okay, so we are going to talk about what is Power BI Direct Lake. Before I talk about Power BI Direct Lake, I'm going to first show you an object that we create here. We call it a lake house. We store the data in that lake house, and then on top of it, we'll create a direct lake, which I'll tell you what it is. So consider this situation that I have data coming from some source, data sources, Excel file, SQL Server, CRM, whatever it is, right? I want to capture that data, store it in a data storage place. If you do that with Power BI does have its own storage place, but it is only proprietary for Power BI. You cannot use it other places. I want to have this as an actual database storage place. Lakehouse is the object we use in this environment. So when I'm here, and if I have the Fabric licensing, I can go to Fabric Portal. Let's say these are the workloads that I have in Fabric Portal. I can choose any of these. In this case, I'm using data engineering. The type of object I can create here, for example, is a lakehouse. I would call this, would you still call this POG, Power BI User Group, or?
POG.
Okay. POG. Let's do POG. Okay. POG Melbourne Lakehouse. Okay. Consider Lakehouse as a database. This is a term generated from data lake, data warehouse. Combine them together, Lakehouse. This is a place that you can store files and tables. Here you see I have two options, storing files and tables. This can be tables like data tables that you have, your customer dimension, your fact sales table, your date dimension, whereas files such as your PDF files for your invoices, image files for the profiles of your customers, for your products, things like that. At the moment, if you want to build a Power BI solution that you need some files with it, you have to save those files elsewhere, right? You have to save them in OneDrive, in SharePoint, in ADLS Gen 2. Here, it gives you an option to save both of them in one place. Anyway, I'm going to load data into this. There are different ways that we can get data and load it into this area. One of them is what's called as Dataflow Gen 2. Now, most of you said you are working with Power BI. How many of you using Dataflow in Power BI? Not quite a lot. Okay. Dataflow is equivalent of Power Query. Everyone here familiar with Power Query? Okay. Power Query is the data transformation engine within Power BI. When we open Power BI desktop, when we connect to a data source, that component that does connection to the data source and do the data transformation and load it into the Power BI semantic model, that is Power Query. This data flow is Power Query online. That is a big difference. And when you run this, the output doesn't go inside Power BI directly. It goes elsewhere, right? It goes somewhere else. In this case, this is Dataflow Gen 2. We can choose where that destination is going to be, which can be actually the lakehouse that I generated, right? So let's go and do this little example. I'm going to use one Excel file as a source. So here it is. Copy the link. Similar to Power Query in Power BI Desktop, I have this option to go and choose any of the data sources available. You see, this is basically similar to Power Query in Power BI Desktop. In my example, I'm getting data from Excel. So let's select that. This is the path for my Excel file. It would scan that file, find all the tables that I have in the preview. I would go and select those tables. Now we are using Lux internet connection. So if something something disconnects, that's Lux from dying. Okay, I'm selecting customer table, product table, category, subcategory. I'll do a little bit of transformation just to give you a feeling of what this looks like. So then I will create. This would add these tables within this environment, exactly similar to Power Query editor in Power BI Desktop. Consider this as online Power Query editor. It is pretty much the same. There are minor differences. There are things that you cannot do here as you do it in Power Query in Power BI Desktop, but those are like 5% of the thing. 95% is exactly the same. You can actually go to your Power Query in Power BI Desktop, copy the scripts or queries from there, come in here and paste it. You can even select everything, like go to Power Query, Control A, Control C, come here, Control V. It will bring everything, folders, parameters, functions, everything. Okay, so these are my tables. And similar to Power Query, this is the preview of the data. This is like the list of tables. Over there, I have steps. Now I'm going to just do a few simple transformation. I'm still waiting for this to load this. Yep, pretty much done. Here we have also this interesting diagram view, which if you haven't worked with Power Query data flows, you haven't seen that. We don't have this inside the desktop. So this diagram view basically gives me ability to do the transformation, but it also shows me in a nice diagram style. So here I want to combine these three tables together, build a flattened product table. So what I'll do is from the dim product, I would say merge this as a new table with the product subcategory based on product subcategory key here, subcategory key over there. You can choose the type of merge. You see how nice this UI is compared to what we have in Power BI Desktop. The UI is actually getting similar in all those environments. So even in Power BI Desktop, we would have similar UI like this in the future. Okay, here it is. So you see that nice diagram, merging this together. I'm going to select this column, product name column, and then this last column. Right click, remove other columns that I don't want. So basically I would have product key, product name. From this table, I would expand it and select product subcategory name and product category key. Then I would use that product category key to merge it with the category table. So basically flattening all of these together, instead of having three tables, I'm going to have one single table. One other step, merge this now with the product category table based on product category key here, category key there, expand. And I'm not going much into the details of what is merged, things like that. You already know that. If you don't know that, that is another session to do. It's not time enough. There's no time enough to talk about it in this session. Okay, so expanded all of these. Now product, category, subcategory, all of that in one table. Here it is. I'll remove this category key column. I don't want that. And that's it. This is my product table, right? I don't need those three tables anymore. I'm going to rename this. Okay, doesn't like my double click, so rename. Let's call this product. Okay, now what I'm going to do is I'm going to load these into that lakehouse we have created Remember that lakehouse we have created originally, which is like a database. We want to load all of these into there. This is Dataflow Gen 2. Difference between this and the Dataflow that we used to create in Power BI, which is Gen 1, is that here we have data destination. So you can set an output for your table to be one of 4 destinations: Lakehouse, Warehouse, KQL database, which is like an event house database, and Azure SQL database. Because I have created this directly from the Lakehouse, it automatically set the destination of my table to that Lakehouse already. But I'll go through that setting just once so that you see what it looks like. So here, this is connecting to my Lakehouse. Let's go to the next step. Okay, this Lakehouse is in this workspace. Expanding that. Here is my Lakehouse. I don't have a product table in there, so it is going to create a new product table. If I have a product table in there, I would have the choice to say, for example, this new data that I'm getting, go and append it in the existing table, or I would be able to just say, for example, replace the data, right? I'm going to replace just the automatic setting, nothing special in here. So this is basically going to put that as a destination. It's not loading it in there yet. I have to publish it so that this process is done. Now, this product table, fact, internet sales, and customer table are the tables that I want in my Lakehouse, but I do not want these 3 tables because I have them in the product table already, right? So I'm going to remove their destination. They are not going to the Lakehouse. Remove that destination. And then the next one. It is also quite possible that you have one data flow with a couple of tables going to one destination, a few other tables going to another destination, like 2 of them going to one Lakehouse, 2 of them going to another warehouse. It is not a good practice, though. I would not suggest, because then it would be really hard to go and find out where everything is going. Anyway, this is done. Let's rename it and call this Dataflow Melbourne Hog. Publish. The publish process is going to save all the metadata things, changes that I have done, MS scripts, all those configuration in a JSON file behind the scene. This is a JSON file. Once that is done, this is that publish process. Once that is done, it would go and refresh the data, and that would be the time that it would have those things stored in the Lakehouse. Okay, we have to wait a little bit until this is done. Any questions now?
When you do the replace,
Yes.
How does it know what to replace based?
Replace basically means that wipe out everything.
Okay,
That
it's
is
not a row by row.
No, it's not a row by row.
Okay.
And append means that whatever is there, I don't care, just add these into that. So even if you have a record already there,
Yeah.
and you are inserting the same record in there, it would insert it. You would have duplicate.
Yeah.
So if you are using append, you have to build your transformation in a way that only gives you the new record. Probably merge it with the table over there, do the left anti-join so that you get only the new records, things like that. Good question. Okay, this is refreshing. Let's go to the Lakehouse and see if we have those tables in here. Okay, here it is. They are still getting loaded. Here it is. These are loaded, so I'll click on one of these. It should be pretty much the same data, right? This is a small data set, so it doesn't really take much time to populate it. Okay, here it is. So these are the 3 tables. You see there's a little sign beside these 3 tables, that little triangle that you see. This is the sign of the format of these tables behind in old Delta Lake format. We'll talk about that very shortly. That is actually the main subject of this session. That is what the Power BI Direct Lake will use. Before doing that, I'll just show you one thing about this Lakehouse. The Lakehouse automatically always comes with something we call SQL Analytics Endpoint. This is like a database, right? So you should have all the database capabilities with this. Then I switch to SQL Analytics Endpoint. This would look like exactly like a database. It would show me my database schemas. All of these at the moment goes under DBO schema. I haven't created any other schema. I can go and create views, stored procedures, functions, exactly those things that you go and build in a database environment. You can even go and query this data in here. So if I'm a SQL developer, I would be able to go and do things such as select top 10 star from product table. You can join it with some other tables, like your normal T-SQL statements, you would be able to write it. Not only from here, you can even go here and copy this SQL connection string, go to a tool such as SQL Server Management Studio. How many of you are by the way, database people? Not a lot. Okay. SQL Server Management Studio, or what we call it as a SSMS, is a tool for database developers. They basically live with that tool, right? It's like Power BI developers. They open Power BI desktop 9 in the morning, they close it 5 in the evening. Same thing with SSMS for database developers. So what I'll do here, I'll connect to that. You need to do the authentication. Oh, yeah, taking time. Okay. Now going back here, when you connect to there, you are actually connecting to that workspace. So in that workspace, if you have other lake houses, other warehouses, you would see them all. Then under databases, I would see this database that I just created, or this lakehouse. You see there are 2 other things. Those staging lakehouse and a staging warehouse, those are automatically generated using Dataflow. It's a good practice usually to have always a copy of your data in a staging, and that is what that Dataflow automatically does. So I see the tables here. I can go ahead and build my queries, stored procedures, everything that you do normally as a database developer, you would be able to do that in here. So far, we haven't talked about Direct Lake yet, right? We are getting to that. Okay, so let's go to that particular structure of the tables. Where was that? Here. So back to here, we talked about the fact that we have our data stored in that format. Okay, no, nothing. Refresh. Okay, switching to the Lakehouse Explorer. We call this window Lakehouse Explorer, a place that you see your tables and files. So what we are going to do is talk a little bit more about this structure of table, what this is called. My slides. Here it is. Okay, that's the style of table, that format of table is something called Delta Lake, not Data Lake. Data Lake is a different thing. Delta Lake is a different thing. Like there are so many words in the in the dictionary. Why they make it so complicated? And that triangle actually is this triangle. This is an open source format of storing data. It is a format that is used by Spark. Spark is an open source platform for managing big data, parallel processing engine. Behind the scene of that lakehouse that I've created is not a SQL Server engine. Behind the scene of that is actually a Spark engine. Spark is a parallel processing engine. If you have large volume of data, it would process that in a really fast way. And that is one of the reasons why we create notebooks as a data engineer to work with that engine. That engine understands a specific format of tables called Delta Lake format. This is basically a format that data is stored in it. Each table is stored in that particular format. I'll tell you what that format is. Benefits of that format of storing data, of course, this gives you ability to work with that data as a normal database. Like normal transaction you do on a database, update, insert, delete, things like that. It also gives you a versioning on your data and time travel one of the really interesting features of this is the time travel, which basically means that I can look at yesterday data even though my data got updated last night, right? Something like a snapshot. Yeah, we call it time travel, but basically it's a snapshot, right? And it keeps that a snapshot for like 30 days, which is quite interesting. It comes with some other benefits as well. But let's talk about the structure. A structure is like this. Let's say if I have that customer table or product table, there will be a folder for that product table. Under that folder, I would have a bunch of files with the extension of Parquet. And then there's a subfolder, log folder. Under that, I have some other files, JSON files. So what are these? The Parquet file is a type of file that stores data, like CSV is a type of file that stores data, right? Everyone familiar with CSV? Something like a text file, right? It stores the data. When you open a CSV file, you actually see that data. It's a row-based format. Parquet file is not like that. It saves the data, but it's not row-based. If you open it, you cannot actually read it. It is column store-based, meaning that if you have duplicate values in your data, it's not going to save your duplicate values like one by one. It is going to save only one of them, have an index from where this started, where it's ended. It does a sorting before that. It does go through an algorithm to do that saving, but it saves it much more efficient than the CSV format. You might have a CSV file which is like 100 megabyte. If you convert it to Parquet, it might be 10 megabyte. It might be sometimes 5 megabyte, right? It depends on a lot of factors, like how many redundant values you have, things like that. So it's much more efficient when you write it. It is also much more efficient when you read data from it. It is saved in a way that it's better for analytical purpose, right? That is why this format of storing data is used within Delta Parquet structure. Here we would have data in this format, not in CSV format, right? Because we don't want to read it. This is the Spark engine wants to read it. Now, what about the JSON files? JSON files here would have the versioning information on those Parquet files. Not all of your data is in one of these, right? They come in different files. The next time you update your data, the next time you insert new data, most likely it would generate new Parquet file. These JSON files would also be added. The next JSON file would tell you that yesterday, 8 p.m., that file 2 Parquet file generated. For example, this morning, 5 a.m., when the refresh happened, file 3 Parquet file generated. That has that timing of when which Parquet file. And that is what makes that time travel possible, right? Okay, let's have a look at these in practice. So here I have these Lakehouse tables. I can click on any of these and go to view files. Okay, here it is. So these are the Parquet files. If I click on it, we wouldn't really see anything. They are not human readable. This is the log folder. Inside the log folder, I have those JSON files, right? Just to show you what the JSON file looks like, it is something like this, right? It tells me that at this specific time, this is a timestamp format, Unix timestamp format. It's equivalent to a particular time. This Parquet file has been added. This is probably the time that I did the refresh of that, whatever data flow was, right? And these are what Spark Engine uses to do that, that time travel and things like that. So far, this is Delta Lake, right? But this session is about, it's not about Delta Lake. This session is about Direct Lake. Lots of similar words. In Power BI, we have a few different types of connections, right? We can have import data. We can have direct query. We can have live connection, composite model, and this new mode of connection called Direct Lake. Let's talk about this. Import data. When I open a Power BI desktop, when I connect to Excel file, SQL Server, any of those sources, one of the default options usually is to import data. What the import does, import would create a copy of data from that source, bring it into the Power BI. Power BI has its own, like a little database storage. It's a file format storage. We don't see it. It is underlying storage inside program files. There's a folder. It has a bunch of files over there. Usually they are hidden. You never get to see them. Even if you can go and see them, you can't understand what it is. It's like a binary file. Those files are storing data in column store format because it is much more efficient to store it in a column store format. It would be much smaller. And it is also much easier to do analytics after that, right? That is what Power BI does. And that is what makes this mode of connection the fastest mode of connection possible. When you build a Power BI solution, we always recommend that import data. This is like the best type of connection. You would have full flexibility in your Power BI, DAX, Power Query. Also, you would have a best performance, right? This is import data. However, import comes with two big limitations. One of the limitation is the size of your file. Depending on your Power BI license, this can be a limitation. Like if you have Power BI Pro license, for example, this is 1 GB per file. If you have premium licenses, depending on your premium, this also has different caps. Another problem with that is the need for refreshing the data, because that data doesn't get updated automatically, right? You have to schedule this to refresh. And by the time that you refresh it, you would have a new data, but sometimes you might want much more fresh data in a more frequent basis, rather than just that hourly or half an hour or whatever you want to do that, right? We have another type of connection called direct query. Direct query is saying that data lives wherever it is in the SQL Server database. Usually the source of this is a database system because they have to support a SQL query language or something like that. So data lives in there. I will not copy the data in Power BI. I will just bring the metadata, table names, column names, relationships, data types, all of that. Then in my Power BI report, I would have some visualization. These visualization would, like whenever I do something like select a filter, slicer, they would create a SQL script. This SQL script goes to that data source. The result of that get generated over there, come back to Power BI, then I would see the result, right? In one Power BI report, we don't have one visual, right? How many of you have a Power BI report with one single visual? You have usually like 4 or 5 visuals, sometimes even more, right? This means that multiple SQL queries usually are sent to the data source. The result comes back. This is like super slow. This is a really slow process. Sometimes you even have a gateway somewhere in the middle of it, right? This is a really slow mode of connection. This is a type of connection that we would not recommend at all because of that problem of performance, right? However, the benefit of this is that you don't need to refresh the data, right? Every time you look at your report, you are looking at the data as of that time, right? Now, what is Direct Lake? If you think about import data one more time, I told you that when we do the import data, Power BI gets data from that source, brings it, store it in its own file format, its own proprietary file format, as a column storage, right? So that makes sense when I'm getting data from SQL Server, when I'm getting data from Excel, when I'm getting data from a source that is not in a column store format. But when I'm getting data from my lakehouse or my warehouse, which is in Parquet format, which is in column store format, is there a point for Power BI to create a copy of that column store data, store it as a column store data? It doesn't really make sense, right? Why should we do that? Why shouldn't we directly connect to that file and read that, right? Because that is the format that we already have. So what Power BI team did was that they made some changes in the engine so that when Power BI connects to a lakehouse or a warehouse that has this Delta Lake format, it considers those files as its own file. So in fact, it is the data already imported there, right? It doesn't really need to import it again. But because that file is also the file for that table, as soon as you get a new data in that table, you have it immediately in your Power BI. So it it acts like a direct query in terms of freshness of the data. It doesn't really need to populate it or copy it again. In terms of performance, it acts like import. This type of connection is called direct link, right? Let me show you how this works. So for this type of connection to work, you obviously need to have either lakehouse or warehouse, anything with this Delta Lake format of the tables. So here we have that. I'm going to the semantic model design of this. This usually comes with a default semantic model. Both Lakehouse and Warehouse, they come with a Power BI default semantic model themselves. This is that semantic model. It has my tables. I can go ahead and create relationships and things like that in this. However, it is not related to use default semantic model. It is a little bit like old editor. Usually what we'll do, we'll go and create a new semantic model from this. I'll select all the tables that I want in here. And I'm going to call this custom semantic model. This custom semantic model will load the new version of model editor, which is more like the Power BI desktop model editor. This model editor isn't really much like the Power BI desktop. There are a few things that you cannot do in here. For example, you cannot do calculation groups here. You cannot do row level security here. But in that custom semantic model designer, you would be able to do those as well. Okay, this is taking some time. Time for another question.
What are the cost implications of direct link versus import?
You pay for that capacity, basically. So there isn't any extra cost. You would probably even save something because with the import mode, you are creating a copy of data, whereas with the direct link, it is just that data itself. So you would have saving a little bit even on the cost. It's not a big saving, but just a little bit even more saving.
But is the compute similar? On the
Compute
space,
is similar,
capacity?
yes, because it acts exactly like an import. So compute-wise, exactly the same. Yeah. There was one more question. No?
So how do you do the time travel?
I'll show you an example of that later. Okay, you see this model editor that is much more similar to Power BI Desktop? This is what I'm talking about. So when you create a custom semantic model, you see that. With the default semantic model, you don't see it. This is the model editor online. So I don't really need to open Power BI Desktop. I can build my data model right over here. For example, let's say we would connect product key to product key. And then what do we have here? Customer key. Let's create a connection based on that too. Customer key. You have full modeling capabilities basically in here. I can go and hide some of the columns if I don't want them. I can, for example, go and select something like sales amount and say this is a format of currency. How can I mute this thing? Format of currency. Yep, here it is. With, let's say, 2 decimal places. Similar to the modeling you do inside Power BI Desktop, you can create hierarchies. You can do most of your modeling thing. Here at the top, even you see we also have options to create calculation groups, row level security, things like that. The only things that you cannot do in here are these two. You cannot create calculated column. You cannot create calculated tables. And the idea when you create a lakehouse is actually to don't do that here. To go and build it in the lakehouse, right? Using your data flow process, using SQL, whatever transformation option you use, you build it over there. Once you build it over there, here you can use it. Okay, so this is my semantic model. Now let's go and build a report on top of it. Before doing that, when I hover on these, you see that it shows the storage mode as direct link. This direct link. This blue stripes basically is a specific type of storage mode for tables, which is dual. dual in this case means that it has a copy of direct lake and a copy of direct query in case it needs to fall back. I'll talk about that advanced part of it a little bit later. Let's for now just go and create a new report from this. Okay, so here I'm going to build a sales amount, card visual, nothing really complicated, just that. Let's say this is my report. Very beautiful report. In the page configuration, I'll set this to page refresh. This is not a semantic model or dataset refresh. This is just the page refresh. So I'm setting it as a page refresh to refresh every 1 second. Sorry. Can we mute this thing? Skip that. Okay, every second. So this means that this would refresh every, come on, go down. This would refresh every second. Let's save this report to refresh. Okay, you should see there's a little refresh happening on the visual every second, right? But this is just the visual, the page refresh. It's not the semantic model refresh, because semantic model in direct lake scenario doesn't really need a refresh, right? So this means that if the data behind the scene gets updated, this should update pretty soon, right? Let's go and see it. Now, what we have in here is a lakehouse. Lakehouse, the way that data can get updated in the lakehouse is either I get the new data in that Excel file, run that data flow again, or I just run an update command. I'm going to run an update command, and I would use a notebook to do that. Notebook is a tool for data engineers. As a data engineer, I can connect to this lakehouse. Creating a connection to the lakehouse. This is that lakehouse. Then you can write a code in here working with those. And there are like 4 different languages you can use in Notebook: Python, Scala, Spark SQL, Spark R. If you are in data engineering and data science space, this is usually the type of tool that you would use. Like exactly that scenario that the Power BI developer 9 to 5 is Power BI desktop. This is like 9 to 9 probably in this environment. Because these 4 languages, each of them have quite a lot of powerful features. Like Python is good for deep learning, R is good for analytics, Scala for big data, Spark SQL for working with tables, things like that. They can give you pretty much everything you want. And in one notebook, you can actually use all of these languages together. Like one cell with R, one cell with Python. Such a powerful thing. I'm, however, going to just use the Spark SQL. So, connecting to this, basically, I'm just running a simple update command. I don't need this line too. So update, fact, internet, sales, set sales amount to just some crazy value. This means that every single transaction in that table would be this. There are like thousands of transactions in that table. Let's just run this. While this is running, I'll just show you the report one more time. So the report is $29 million. So once that runs, that should change. It usually takes a little bit of time to establish the connection. This notebook uses the Spark engine behind the scene. It creates a connection to that Spark engine, which we call it the Spark instance. Once the connection is created, then running it shouldn't usually take much time. Okay, yep, looks like done, right? Yes, no, still running. Okay, I think it is done. So let's go to the report. This number should change just like that. It's not always that fast. Sometimes it is a little bit slower, depending on how many transactions are getting uploaded, how many, because those Parquet files sometimes get generated based on the batch of data entries. But usually it is a fast operation. And this is not a direct query. This is the performance of import with the freshness of the direct query, right? This is what we call as a direct link. Now, there are a few things about this. The first thing about this thing is that, let me go to this semantic model. Here it is. When I go to the semantic model, when I go to the setting of the semantic model, I have this refresh configuration. What is this really? Because we talked about the fact that direct link doesn't need refresh, but what is this refresh? This refresh basically is not really a refresh. There's a different term for it. It's called reframe. When the new data gets added to this table or updated or things like that, new Parquet files generates, right? Power BI is still looking at that Parquet file at the time that the report was opened, right? How does Power BI knows that it should look at the new Parquet file? There should be a process to inform that, right? This is reframing. So it's not really refreshing the data, it's just pointing to the most recent Parquet file. This is that, right? So this should be basically a different term, reframe. Yes?
Is it based on those JSON files? So it's looking at
That is right. Yeah, the latest JSON file usually tell us which Parquet file we should look at. And that is what this is doing.
Does it only have to ingest the latest Parquet file because all the previous are already?
Yeah, and it doesn't even need to ingest it. It just need to look at it or
Okay.
yeah, whatever we call it, browse it. Okay, now a question for you. Do we ever need to turn this off? Or what situation might happen that you might need to turn this off? Why don't we want to get it refreshed?
build the report. So
These can be scenarios, but there is usually much more relevant situation. Let's say I'm running my ETL process, right? My data flow pipeline, whatever, and it takes some time. Sometimes some minutes, sometimes hours. During that process, some of your tables are loaded, some of your tables are not. If you look at the report in the between of that process, you probably see some wrong numbers, right? Having this on, this means that even in the middle of those processes, you would see some up-to-date numbers, and those might not be correct, right? So in a situation like that, you might consider turning this off and then adding a refresh semantic model activity in your pipeline at the end of your data flow refresh or anything like that, right? That is a kind of situation. Those situations that you mentioned also can be an example of that. So far, good? Okay, let's see if we get to, yeah, we talked about reframing. I'll talk about a couple of things more and then we'll see if there's any questions. So direct query is a great thing. However, it comes with some limitations. One of the limitations you already saw. You cannot create calculated table. You cannot create calculated column. But that is not, I wouldn't consider that as a big limitation because the idea in this case is that you go and build them in the lakehouse, right? Another limitation as of now is that semantic model, I can only build it in the web editor. I cannot build it in the Power BI desktop. So that 9 to 5 Power BI developers using Power BI desktop, you cannot use Power BI desktop to build that. You can use Power BI desktop for your reporting part of things, but the modeling should be done in the Power BI website. This feature, however, is coming very soon. Like next few months, perhaps, something like that. I'm just saying something, but usually very soon means that something like this. So that would not be also a blocking thing. There are some other situations that would cause what we call as fallback. Fallback basically means that there is a situation happening in the model that caused this from direct lake to go to direct query. So suddenly the performance goes way down, right? What are the situations? First, because you have different capacities in Fabric, different capacities will give you different compute power. If you exceed some of the limitations that you have in your compute power, then it would fall back to direct query, right? For example, with things such as F2 capacity, F4 capacity, with those, probably it is more likely to have fallback on a big model, whereas something like F64. Another situation that might happen, which calls fallback to direct query, is if you use a SQL view or something like that as one of your tables. So for this example I built, I basically used only tables, right? But if I had a SQL view and added that in my Power BI semantic model, that would have been a fallback to direct query. If you ever build a composite model where you have some tables as direct query, some tables that this doesn't work with that, right? That would also fall back to direct query. So these are the limitations. In terms of your capacity limitations, these are what they call as guardrails. For example, on a F64 capacity, it's like 1.5 billion rows that if you exceed fetching more than that, it would fall back to direct query. This is still a lot of rows, right? But you have to consider your reports probably get used by a lot of users and all of that as well, right? So these are guardrails that you have to be aware of. Now, what happens when that switch happens, when the fallback happens, right? I'm using the direct leg, everything performance-wise is good. Suddenly it falls back to direct query. You can change that behavior. You can say that fallback behavior, I do not want it to happen, right? I would say, let's do only direct leg. This means that if a situation like that happens, you get an error. You might say getting an error is better than going to that slow performance, right? So this is why this is you have the choice to change it, right? Or you might say I would only do it as a direct query, which doesn't really make sense because if you wanted to do direct query, you would have created a direct query model. Automatic one basically means that it is a direct leg until it hit one of those limitations, it would switch to direct query. The direct leg only is actually a good option to check when that fallback happens, because otherwise it's hard to find out when that fallback happens, right? You want to do some testing, you want to find out if there's a situation that the fallback happens or not, you'll go and set it to direct leg only. You'll do some practices, do some things, and then if you don't get any errors, that means probably you are safe to go with your current capacity. These settings can be set with this type of scripts using something like Tabular Editor, sometimes SQL Server Management Studio, Visual Studio, you can run this code and set that configuration. Any questions? Okay. Let's, here it is. Okay. Under what circumstance does direct leg fall back to direct query? Yep, we talked about that. In what circumstances will not get import like performance fall back to direct query? Yep, we talked about that. Yep. How CU units will be calculated in direct query mode and how determine how much we need capacity unit. So that is one of the scenarios I talked about. If you are not sure would you have fallback situation with your current fabric capacity, you would go and set it to direct leg only. That's okay. Set it to direct leg only, then let it run, do some experiment reports, get your users to do some of their hacks and things like that. If you hit that error, that means your capacity isn't enough for that situation. You'll go one level up. That is usually the best way to do that. There are ways that you can use tools such as DAX Studio to monitor if fallback to direct query happens, but this is the easiest way to check that. Okay, is there any other questions here?
A question.
Yes?
Is it possible to use like that time travel
Mhm.
and like say point to what the report showed yesterday?
What the report showed yesterday, probably not, because in your report, you probably also have measures and things like that, right? That time travel is talking about only the lakehouse side of things. On top of the lakehouse, you have that semantic model. In your semantic model, you probably have more logic. If everything you see in your report is basically coming from the lakehouse without any calculations, it might be possible using direct query, right? Not using the direct lake. I'll show you that. You'll understand what I mean. Which is actually good timing for that, because I wanted to show you this time travel thing, how this works. I'm not going to show you the whole example for that, but I'll show you what the script looks like. Here I have another workspace. Yep, here. And in this workspace, I have a lakehouse that has some tables in it. Let's open this notebook so that you get to see what the code looks like. Okay. This is a Python code, by the way. This time travel can be done using SQL code as well if you have a warehouse, but here I have a lake house, so I'm doing it using a Python code. Let's see if I can do zooming. Yeah, that's a little bit better. Minimize that. Okay, so I'm basically reading one of the delta tables in this case. This is the table name. This is a Python code that basically reads a delta table. Right. So far, nothing strange. Then from that table, I get the sum of trip distance, and I show it in here, right? I do exactly the same thing, but this time with this extra option. From the same table, only with this extra option. I'm saying that, well, give me this at that particular times, right? And then get the sum of trip distance. And you see, in this case, we had that difference, right? This is the Python example of it, right? We could have something similar to this in a SQL code. In your SQL code, after you select star from this table, join with that table, where blah, 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 at the end, as timestamp of this, right? You would get exactly the same situation. Now, back to your question that can we use something like this within our report? If you want to use something like this within our report, this query should run on that lakehouse and warehouse. The report doesn't run query on the lakehouse or warehouse unless you change it from that direct lake, unless you make it an actual direct query thing. And in your direct query, you pass a parameter using something like Power Query parameters to a script like this. This could be a stored procedure view, or it can be even a SQL query. And then pass it, you get the result. It wouldn't be that intuitive experience for the user that they go and choose a slider and they see the value immediately. It wouldn't be like that, but you have the option to use it. Snapshots is always stored up to 30 days. So you don't really need to enable it or even disable it. It's always the last 30 days of data is always there. You cannot have more than that. You cannot have less than that. I mean, you can clean your data to have less than that, but usually we wouldn't do it, right? This 30 days was like, I think a few weeks ago, like 6 weeks ago, this was 7 days. They increased it, now 30 days. I would love to have that option as a configurable option so that you can change it. But you have to also remember that this means that all of those extra Parquet files generated, they will remain in the system. It would use a lot of storage, things like that. That is actually one of the reasons this is 30 days. Also in Databricks, it is 30 days. It's not only a Microsoft thing. Any other questions? Yes?
Connection to use direct lake, is that automatic? I mean, like in Power BI desktop, when you connect to any data source, the first thing you get is a dialog that asks you, do you want import or do you want?
Right, yes.
So on this, when does that selection happen?
With the direct lake, it is automatic. Like when you have a lake house or warehouse, it is by default always direct lake. Unless you go inside your Power BI desktop, let me show you this part as well. Unless I go inside Power BI desktop, opening. When from Power BI desktop you connect to that lake house and warehouse, one option is that you can switch it to look at the SQL Analytics endpoint. And then you would have the option to say, I want import or I want direct query. So without that option, everything is by default a direct link. So let's just have a look here. Okay, so here, if I go, for example, and say from one lake hub, let's get data from a lake house. I'll choose this lake house. And then here I would say, well, let's go and connect to the SQL endpoint. When I do this, then I'm actually connecting to that database backend. I'm not doing direct lake anymore. I can go and select the tables that I want. I think it is authentication, yeah. Hopefully it is not multi-factor authentication. Okay, so here I can go and choose the tables that I want, whatever. When I say load, this is the time that it would ask me, do you want import or direct query? Well, yeah. Right. So I actually bypassed that direct lake in this situation. But by default, when you create it in the website, always direct lake. You had a question too?
Yes, can you use it with the shortcuts, table shortcuts?
Yes, we can use it with the shortcut. What is the shortcut? For those of you who don't know, shortcut is if I have a table elsewhere in my Fabric environment, like I have a date table already somewhere else, I can go and use that table and add it in my lakehouse. Now, what was that? Yep, here it is. So in this case, actually, I don't have a date table. So this is a good example, actually. So here I can go and say, create a new shortcut. I have already my date table in another lakehouse. So I'll go and connect to that lakehouse if I can find it where it is. I have plenty of workspaces in here. I think something here. Yep, like that. And then we should have a date table. Here it is. Shortcut basically means that I'm not creating a copy of that date table is still there. I'm just creating a link to that, like creating a shortcut in Windows, right? It's a separate folder. You create a link to that folder. And this is that shortcut table, right? It usually have this little link on top of it. Now, to your question, this shortcut table acts like any other tables in my direct lake situation. So when I go to my semantic model, in the model tab, this table is like any other tables in there with that direct lake connection. Yeah. Yes.
You said you can't do calculated tables in the semantic model with direct lake. Does that mean any PBI or PBX file that connects to those semantic models can't have calculated tables in that?
Yeah, they cannot have it as well. Yeah.
Like that answer.
Do you use calculated table a lot?
Well, there is not in the measure section of a chart. If you want to have it on a category or an axis, you can't do that. You have to have a created table and convert the measure dimension, like histograms, for example.
Yeah.
So yeah, at the moment well, my next thought would be fine. I'll just do a SQL view. You've already said that's off. So
yeah, but you can convert your SQL view to a table. So you can.
That's replicating the data that's already there, which you should be aggregating, not copying.
Yeah, but the calculated table is also duplicating the data in the memory in that column store format, but it's also copying the data. In this case, this is also copying the data in Delta Lake, which is also column store. So pretty much the same in terms of memory.
Yeah, but like how then do the filters apply? Filters from dimensional other related tables.
You still can do measures. Measures will still work, but yeah.
Not as a dimension that, yeah.
Yeah, not as a measure you add inside a column, inside a table. Yeah, not like that.
Is there a solution?
Build it in the data warehouse. Do it the right way.
One more in the chat.
Oh, yeah, okay. How does a user know that the data appearing in Power BI is latest when using default detect changes option? It may or may not have picked up the latest row, for example. Good question. How do we know that? Like, one of the ways probably is to have a date field in one of your tables, I'd say, because as soon as this refreshed, you'll see that value, something like that. This is yeah, you can also do some like select get date, something like that. But that would be a view that would not be direct lake anymore, right? It has to be a table. So yeah, I think adding a date column in a table probably is easiest. And then using that in here. There might be other ways as well, but this is just thinking loud. Yes.
If you create a lakehouse data set here, and then say you've got 5 different analysts wanting to use the same data set, but want to cut it in different ways, is the best way to like write SQL like a where clause, or do you use Power Query to filter like that? Like, how would you filter the lakehouse?
Like the data that you have here, your data analyst, they want to get this data, but part of the data, is that what
Yeah,
you're saying?
so like say the report is for last month only. You would only pull up the facts from last month instead of having the whole history.
For those, I would suggest they use that Power BI desktop connection, like what I showed over here, with that connecting to the SQL endpoint.
Yeah.
Not the direct link. When they connect to the SQL endpoint, then you have full Power Query because you can do import, right? So when I do something like this.
But does that default to the direct query then?
Import.
It's still import.
Yeah, because you can choose import here. So I can say this. Let's say this is my sales table. This is the table that I want to filter. And I wouldn't do load. I would do transform, import. And then in Power Query, I would say dates between this or in the last previous, like the normal import that you do. Right? Because import still has a good performance. Direct query, what it gives you is the freshness of data in addition to that performance. Direct lake, sorry. Lots of similar terms. Yep, okay.
What's the implications on the compute when, let's say you have a report and 100 people are trying to get the data, trying to get the report refreshed? The impact of that?
That would have an impact, but the main impact would really depend on how the semantic model is built. Do you have like heavy measures showed in a metrics visual, 10 different measures across 100 different categories, things like that? Then every user looking at that report is 1,000 measures, 1,000 calculation for every user. You have 100 users, it's like 100,000 calculations. Something like that would have a heavy impact. But if I have some simple charts showing some simple measures, no, not a big impact. There is definitely impact per user, per calculations, per interaction. All of these would count in your compute usage. Yeah.
And if we don't set a tile refresh, like the 1 second window that you said earlier, if that's not being set, then the page, when you refresh the page, that's when the
you'll see that. Yeah. Or if you close it and open it again. Yeah.
I think there's one more online.
Okay.
He's posted it twice, so he's very keen.
Oh, okay.
It's the composite model one.
Which one? Oh, the one at the top. How do composite model aggregation work in Fabric? Composite model first doesn't work with direct lake, right? So no composite model with direct lake. That's the answer. But if you want to do composite model in Fabric, yeah, you can do that. You can do import. Like you can still do import. Nothing here stops you to do your normal Power BI thing, right? I can use that lakehouse, warehouse, and import that data, do my composite model aggregations, calculated tables, heavy measures, whatever you want, like kill Power BI with it. You can do all of that. Nothing stops you from doing that. Nothing changed in Fabric the way you did it in Power BI. You can still do that. Okay, then what we do modeling Fabric Power BI service? What would be use case for Power BI desktop then? Well, there is still a use case for Power BI desktop because still it's a faster place to develop things. I don't think Power BI desktop goes away. Probably it would be more connected to the online services. But yeah, that would still remains there.
I think Microsoft's made no secret that they're trying to get feature parity between the web and Power BI desktop, but that's not easy. And so I think Power BI desktop's going to be the place to be for day-to-day development for a while.
So how will you get the map people in without having to use VMs?
That's exactly right.
Yeah.
Tableau heads.
Yeah.
That's right. Yeah.
Tableau heads. Yeah. All right.
Okay.
Questions? 5, 4, 3, 2, 1.
Just one final comment. If I might.
Yeah.
There's one thing about Lakehouse that I know that you probably don't know. There's a Lakehouse restaurant
Really?
in Alsford. If you want to take a day off, Greg and I'll take you out to lunch.
Thank you. I appreciate it. Is it really called Lake House?
It's called Lake House.
Wow,
You go there,
okay.
take some
I
photos.
should take a photo of it.
Probably need to go there. It's pretty nice.
Yeah, okay, that's cool. Thank you. Yeah, this time I'm flying tomorrow, but yeah, hopefully next time.
You can make impact.
Oh, is it expensive? Is it expensive? Wow, okay. So I need to earn some money first.
Let's hear it for Reza. Thank you.
Thank you.
Well, a couple of weeks, eh? Really good. Lots more to come. We've got lots of interesting people and things coming up later in the year. Might be some things that Reza are doing, but I don't know if he's spoken to anyone about it yet. So we'll talk about that another time.
You can talk about it.
We can talk about it.
Yeah.
Yeah. Well, I'll let you say because I don't want to.
Okay. We are going to have a one-day conference here in Melbourne,
Yes.
3rd of December. Yeah,
I think it's early December. Yeah, 3rd of December.
3rd of December. Okay, so you'll know about it. It is going to be in city somewhere, and once we have it, Greg will also let you know, guys. I think we have like 4 different tracks, lots of sessions, so
Yeah.
would be fun. Lake House Restaurant, yeah.
That's a good idea.
Yeah.
So some of you might have gone over to Auckland. So Reza's running Sydney, Auckland, and Melbourne conferences, and so we're going to have a conference finally. Hey, we can do a conference and I can hang out. So that'll be good. So I'll keep you guys posted on when that's getting announced. And I think you usually do like an early bird ticket and things like that. So anything like that, if we get a plug discount or a early bird ticket, I'll send those codes through so you guys can get them.
And it is not going to be expensive, probably cheaper than the Lake House Restaurant.
That's only direct ingestion there.
Okay. Full ingestion.
All right, thanks, folks. We'll see you next month. I'm not sure what we'll be doing, but it'll be great, I'm sure. So.